going to talk about the evolution of log fences in the North American scene. Log fences have been part of the culture for protective and agricultural fencing wherever there is an easily harvested source of logs. This presentation focuses on North American fences that have evolved since the original settlements of the early 17th century. Although the early settlers brought some provisions with them, it was imperative to establish an agricultural base because of the long and unreliable supply lines from Europe. The forests that had to be cleared to grow crops provided a ready source of logs both for defensive works and habitations and to protect the precious crops. Although stone was also available, the less labor-intensive logs were first choice, and for nearly 300 years continued to provide for these needs, until in a survey in 1870 it was established that almost 6 million miles of log and split rail fences were in use. Shortly after, with the availability of cheap steel and for rail transport, barbed wire and then woven wire came on the market at prices that the more prosperous farmers could afford. The total mileage has declined from that time, but use of logs from the forest for fences has continued to this day in regions where soil depth and fertility is lower. The early fences required to keep wildlife from the crops or to keep cattle from straying used select logs, and the designs reflected the opportunity cost of labor. It seems logical that the first designs were built on top of the ground to avoid laboriously digging post holes by hand to below the frost line, and these fences used no or little metal. 3 designs achieved these criteria: the names inter alia, snake fence, bunk fence, and the A-frame fence. In the following presentation, we will show how each of these designs evolved over the centuries and how newer designs coexist with the old, as the choice of what fence should be built has always been with the owner. The snake fence. It is likely that the snake fence was the first choice of the earlier settlers. It could be built on the surface. It was self-supporting, it could use logs of any size, and because of its inherent stability, could be built to any height. Its construction was simple enough that the older children in the family could be taught to build it. It had its disadvantages, however. The zigzag plan required a wide band of the cleared line that had been so laboriously gained. The logs were round, and a cow seeing greener grass on the other side of the fence could push the top log off, and by persistence lower the fence until it could jump it. The first modification was perhaps to notch the top log so that it was more difficult to displace it. A more positive solution was to mount pickets at the junctions, dug perhaps a foot into the ground, and to tie them together at the top. 1, 2, 3, or 4 pickets could be used, the most common being 2, either transverse or in line with the fence. The fence still occupied a wide band of hard-won cleared land, and a trade-off between land and labor solved this in regions where post holes were practical. By digging in 2 posts at each junction, the logs could have lateral support, would maintain the same height, and could not be displaced. This design has been called the Ferguson fence. The same benefit could be achieved where rocky soil didn't permit digging post holes by cutting a sturdy bunk, drilling 2 holes the desired spacing apart, and driving pickets into them to give lateral support for the logs without digging post holes. In all these designs, vertical spacing between logs depended on the diameter of the logs, unnecessarily small if the logs were small. By putting spacers between the courses of logs, the number of logs could be reduced while still retaining the other desirable features. The spacers could be either stone or wood. When wires became economically available, it was a substitute for the spacers. Of course, the integrity of the fence was dependent on the durability of the wire, certainly less than that of stone. A further saving could be achieved by digging one post hole rather than two, and fastening poles or split rails rather than logs to the single post. This was normally done with spikes, though wire was sometimes used. This design was called the pole fence. The poles might be touching, or could be spaced apart to save logs where, for example, large livestock were being confined or barred. The pole fence was effective, but was rough-looking, and a neater fence was developed for horse farms, etc., where appearance was important. With more sophisticated machine tools available, the design called the post and paddle fence satisfied the modern requirements. In earlier times, the same requirement for appearance was met by the post and notch and the post and dowel fences. We'll now go to the development of the bunk fence. This design, like the snake fence, had the same advantage that it could be built without digging post holes. It used logs of any size, but fewer than the snake fence, because it inserted bunks or spacers between courses. It also laid all logs parallel to the fence line and depending on the length of the bunks, saved space. But because the logs were round, the top log could be pushed off by livestock. The problem could be ameliorated by notching either the bunks or the ends of the logs. A better solution was to place pickets, as was done with the improved snake fence, dug a foot into the ground at each junction. 1, 2, 3, or 4 pickets could be used, with 2 being most common. Originally, the tops of the pickets were tied together by willow withes or by a yoke drilled to hold the top of the pickets, but now the tie is done by wire. Where the earth cover was limited, sometimes a drilled bunk was laid at the junction, drilled with 2 holes into which the bottom of the pickets were driven and the tops tied in the same way. It is apparent that the improvement of the 2 designs, snake and bunk, have converged so that both designs thereafter followed the same development path, as we have discussed before. We'll now go to the third family, which is the family of A-frame designs. The purpose of the earliest version of this design, called the Indian fence, may have been to make the barrier difficult to climb, whether as a protective stockade or as a livestock barrier. It required a sturdy terminal post, and the top of the first log was secured to it, the other end resting on the ground. The top of the second log rested in a V formed by 2 pickets resting on the first log, and so forth along the fence line. The bottom of the pickets had to be dug into the earth so they could support the weight of the log on them, and this permitted the fence to be built without any wire. Later, the addition of wire made for a stronger design. Many variations of the A-frame principle was developed over time, some useful and some not. In Canada, 14 patents were taken out for variations of this design. The goat fence, widely used on the prairies, used an asymmetrical A-frame and placed the rails on the long leg. The livestock had to be located on the side of the short leg. To provide inline stability, a diagonal rail tied the 2 adjacent A-frames together. Another design permitted livestock on both sides of the fence by suspending the lower rails from the A-frame. The previous design had stability problems. These were solved by the Russell fence, patented in Canada and still used in British Columbia. It still suspended the lower rails from the A-frame, but added inline braces to make a more stable structure. A variation called the Taylor fence was developed in eastern Ontario, but used a different inline bracing. All the variations discussed above had a common feature, that stability required that the bottom ends of the pickets forming the A-frame had to be dug into the ground, using the earth to form the third side of a stable triangle. The patent fence, common in several Ontario counties east of Peterborough, added a bunk to tie the bottom of the pickets together, as well as wiring each rail to an inline picket on each side of the A-frame to make a stable tripod in each direction. This is the ultimate design of rail fences. The continuing development of log fences demonstrates their adaptability in a changing world, and their value to agriculture in margin areas is obvious. Where rot-resistant wood, such as eastern white cedar, is available, whether poles, split rails, or logs, they can be built by hand labor and will last far longer than wire fences. As heritage items, they have even now achieved a place around public buildings and estate homes. The changes shown are only a few of the variations that have originated in the work of farmers and skilled workmen in the rural communities across North America. Let us hope that the technology will not be forgotten and that log fences will continue to grace our rural landscapes. For those that wish to study the subject a little deeper, I've written a couple of books, one called 400 Years of Log Fences, which describes 14 types of log fences and shows how they may be constructed. The second book is a more general book called Good Neighbours Make Good Fences, which discusses the evolution of fencing from the beginning right through to the electric fencings and some of the later specialties.